We have the first one's simple interest. I mean, those other ones, I guess you were kind of translating. With this kind, I'm going to give you an equation, and you'll just substitute in what you know and solve for the letter you don't know. So simple interest, we say that P is equal to, we say that I is equal to PRT. I is interest. P is principal, or the original amount, is how you can think of it. R stands for the rate, and time stands for, well, T stands for time. Something to notice with this formula, by definition, guys, it's talking about things in years. So everything that you put in this equation, make sure it has been converted to years, okay? Just in case there's ever a question in the future in a harder problem. The way I remember this always, when I was taking math classes, it's kind of like I equal PRT. Anyway, I don't say it online. That's how I memorize the equation. I want you to memorize this. But so make sure you memorize this equation. But that's what I used when I was in school. I know it sounds funny. People always laugh. I don't want to have it recorded and put online, but yeah, whatever. The other one I don't have like a memorization trick. I just saw this one so much and it tortured me. But I had a teacher teaching. I was like, oh, look, I can think of it this way. Okay. It just sounds funny when I'm the teacher saying it because I'm like, okay, that sounds weird. Okay, there's one other formula. It's for when you're talking about distance. It's a distance formula. And again, both of these you need to memorize. Distance is equal to rate times time. And the idea is, this is for uniform motion problems. In other words, the speed's not changing. Speed and direction are the same. I mean, you can calculate multiple distances, like this is distance 1, this is distance 2, whatever. But the idea is that for each one you're using, the speed stayed the same and the direction stayed the same. Nothing crazy happening. Your D, again, stands for distance. Your R is your rate or your speed. And T is your time. Let's do one example of each. And then you guys, I would highlight this page or keep it somewhere. Practice this and make sure you know these two formulas, okay? I expect that you memorize them. First, I'll do an interest one. Will somebody on page 80 read me example 8, and we'll just write down the details? Page 80, example 8. How long is the fee? When was the fee charged? Does it tell us? Just saying she was given this fee. That's probably a monthly statement, we'll say. So we'll say that's a monthly statement she just received. I wish they'd been more explicit. Be forewarned that they might not always be super specific in your homework problems, which is where I get your test questions. Hopefully there's not going to be one like that, though. If it's monthly, how can I represent time? How can I represent 1 month in years? So remember, we're talking about years. Oh, you're saying that 1 month is 1 out of 12 months, or 1 out of 12 months is put on a yearly scale? Okay, so time is equal to 1/12. That was kind of tricky. That was hidden in the question, kind of. So since we're talking about interest, what formula do we know we're going to use of the two you've just learned? The I equals PRT or the D equals RT? Okay, so we know we're using I equals PRT. And we also know from the problem that we're being asked to find the rate, right? So the idea is, even if you didn't see the time, you would, by looking at the formula, you can see that you need to have a couple different letters, right? If you're looking for R in your formula, you know the I, you know the interest, you know the balance. What letter's balance going to be, by the way? P? Okay. T equals this one, time, and R equals right. So that was at least a heads up to say, hey, I should think about the time a little more. Let's sub it in to the equation. So we're using, again, I equals PRT, our interest formula for simple interest. For the I, we're going to put in 8.72. In place of principal, we'll put the balance, which is 545. Times, we don't know rates, I'll put times R times T, which is 1/12. Okay. Our objective is to get what by itself. Can we simplify this? Calculate off the left-hand side. You've seen this in your homework before, haven't you? Remember when you had those letters with stuff being multiplied? You can do that, can't you? Just take the number 545 and times it by 1/12. So what do we get on this side? What is 545 times 1/12? It keeps going forever. Well, there's two options for it. What we could do is write it as a decimal. I'm actually just going to write it as a fraction then. That's what the author does to keep the answer more precise. That's what I'm going to do. If you wrote it as a decimal, I'm definitely okay with that. But I'm just going to put it together and write it like this. The reason is because it just bugs me to round so early in the problem, and we didn't have to. We can write it like this. So we condensed it, we multiplied it together. So now it looks a little better. If I want to cancel this, how do I kill what's in front of R? Okay, so the way you look at it is divide by 12, or wait. So dividing by a fraction means basically you're going to multiply by its reciprocal. Okay. So that's the same as me saying times 12 over 545 on both sides. And of course, remember before when I taught you this, I showed you could do it in two different ways. You could have done it the other way. For me, when I see fractions, I just flip things now that I'm comfortable with it. But again, you can do 2 different steps if you want to. It's okay. Now what do we get? What's R equal to? You probably would have gotten that even if you had made this a decimal up here when you timed it. If I wanted to write it as a percent, if I wanted to write my rate as a percent, R percent, what's it equal to? And that's usually how they're going to expect it. Notice something though, when within the problem, it wasn't as a percent. They don't deal with it in percent form, do they? You have to take care of the percent. Let's do one more example. Okay, this is going to be on page 81. I'm going to use the example from the book again. And this one's kind of in the text. It's the very first one under Objective E. Let's see, it says, if you have distance, you're looking for distance traveled. Okay, for instance, suppose a car travels 50 miles per hour for 3 hours. Because the rate, 50 miles per hour, and the time, 3 hours, are given, we can find the distance. So for this example, that's what the book gives us. They're saying, if I tell you that not distance, sorry. If I tell you that we have a car going at a speed of, what was it, 50 miles per hour? 50 miles per hour. And we know that it traveled at that speed for a time of 5 hours. Can you find distance? The idea is sure. You just learned the formula tonight. Distance equals rate times time. Something to notice. This is not trivial. Units. My speed is given in hours, right? Notice that time is also in hours. When you're doing this, it's very important that you're on the same scale, that your units are the same. So if you have hours in one, you have to have hours in the other. Okay? So this one doesn't have that year requirement, but it is important that the units match. So in this case, we had hours and hours. If they didn't match, you would have to adjust them. Okay, so to get the distance, you just sub in. So distance is equal to, what's our rate? Okay, 50. And what's our time? Okay, so what's the distance? Okay. Now wait a second. Distance is not going to be like miles per hour. It's going to be just miles, right? Now how do we know it's miles? And that's the unit we're already using, right? Because it's talking about miles and hours, everything should be matching. We should be talking only about other hours and other miles. Technically stuff cancels out, but I'm not going to show you that right now. Just know that because the original had miles in it,